This is the exam review for semester 4. The subject is chemistry for grade 7. So we first looked at signs of chemical reactions, and we said that there are 4 signs of chemical reactions. So change in color, shape or size, a release of gas, the formation of precipitate, and the change in temperature. This could be either exothermic, so that's the release of heat, or endothermic, which is the absorption of heat. So let's look at them one by one. Change in color. So an example of this is when we add sugar with sulfuric acid. This gives a black carbon which grows up in the beaker. So as we can see the image here, it contains a black carbon which grows up in the beaker. Second one was the precipitate formation. A precipitate can be formed when adding two solutions together. And what happens is a solid will automatically form. So as you can see here, we're adding 2 solutions. Here a white precipitate is formed. So a white solid is formed, and here a yellow precipitate is formed. And here a yellow precipitate is formed. So an example of this is when you add silver nitrate to sodium chloride, a white precipitate is formed, which is silver chloride. And when you add potassium iodide with lead nitrate, this gives a yellow precipitate, which is lead iodide. Release of gas. There are 3 main gases that are released in a chemical reaction. So we've got carbon dioxide, hydrogen and oxygen. So with carbon dioxide, we test this by using lime water. With hydrogen, this gives us like a squeaky pop when we put a flame next to it. And with oxygen, it relights a glowing splint. So an example of this is when we add hydrochloric acid over chalk, effervescence occurs. This released gas makes lime water cloudy. Then we've got change in temperature. So reactions during which energy is released in the form of heat are called exothermic reactions, and you can feel the beaker or the place that you're doing the experiment in. You can feel that the beaker will get hot, while reactions that absorb energy in the form of heat, when they occur, this is called endothermic. Representation of a chemical reaction. So how do we represent a chemical reaction? So first of all, we need to give an example of a chemical reaction. Let's say, for example, CH4, which you all know is methane plus O2 gives us CO2 plus H2O. Now I know this is not balanced, and we're not going to go into balancing equations now. Okay, it's not needed for your syllabus. So, first of all, we looked at what are the reactants and what is the products. Anything that is before the arrow, these are called reactants. So here, for example, these here are before the arrow, and these are called reactants. Anything after the arrow is called products. Anything after the arrow is called products. So here we have methane and oxygen are reactants, and carbon dioxide and water are products. Then we looked at word equations. In word equations, we just have to write them. So first we have CH4, so instead of writing CH4, we are going to write methane plus O2 is oxygen, so we're actually going to write oxygen. Remember, arrow. Then we've got carbon dioxide plus water. Okay, so we just write it in word form. Then we have chemical equation. A chemical equation is what we've written on the top. So we actually write CH4 plus O2 gives us CO2 plus H2O. Then we looked at mass reactants equals mass products. For example, if I was given the mass of CH4, let's say that is 2 grams, and the mass of O2 is 5 grams, and the mass of the CO2 is 3 grams. So this will be given to you, okay? So this is given, okay? We need to now find the mass of H2O. Okay. So what do we need to do? You know that the mass of reactants equals the mass of the products. So you've got CH4, which the mass is 2 grams, plus, then I've given you the grams, so 2. And the mass of O2 is 5, equals to the mass of carbon dioxide, which is 3, plus the mass of H2O. So we need to find the mass of H2O. So this is 2 plus 5, and then we need, which is 7, equals 3 plus mass of H2O. We remove the 3 to the other side, which becomes a minus. So 7 minus 3 equals the mass of H2O. 7 minus 3 is 4, which equals mass of H2O. We then looked at combustion reactions. We said a hydrocarbon is an element made up of carbon and hydrogen atoms only. For example, CH4, C2, H6, C10, H22. These are all examples of hydrocarbons because it's made out of carbon and hydrogen atoms only. Combustion is an intense chemical reaction that only occurs in the presence of oxygen. Incomplete combustion is due to the oxygen deficiency. A black deposit carbon is produced as well as water. This uses a yellow flame on a Bunsen burner. Now, to give you an example of an incomplete combustion, for example, let's take C2H6. Remember, this is a hydrocarbon, and now it says it always occurs in the presence of oxygen. So here we're going to put plus O2. So a black deposit carbon is produced. So the products is carbon plus, and here we say that water is produced as well, plus H2O. So this is an example of an incomplete combustion. With a complete combustion, this occurs in the presence of excess amount of oxygen. The combustion of gas produces carbon dioxide and water and heat. This uses a blue flame on a Bunsen burner. And I'm going to give you an example of a complete combustion. So now we're doing complete combustion. For example, if I use C2H6 again, always plus O2, because it's always with O2, gives us CO2 plus H2O plus heat. And this is the equation for complete combustion. Okay, only these change. Only these change. So the hydrocarbon that we use change. The rest of the equation stays the same. We're not going to balance these equations because it's not part of our syllabus. But this is the main idea of combustion. And now we'll do the questions for the exam review. So question 1 says, read the text below and answer the following questions. We heat a piece of sodium carbonate. Sodium carbonate decomposes into two substances, sodium oxide and carbon dioxide. Is this decomposition of sodium carbonate a chemical or physical change justified? Now, first of all, it gives us a new substance, so that will show us it's a chemical change. And second, this is an irreversible reaction. We can't get our sodium carbonate back. So this shows us that this is a chemical change. So chemical change because a new product is formed and it's an irreversible reaction. Give the name of the reactants. So that is sodium carbonate. Give the name of the products. So that is sodium oxide and carbon dioxide. Write the word equation of the above reaction. So we write always the reactants and then the products. So we write sodium carbonate and then we put an arrow to show us the products. So that gives us sodium oxide and carbon dioxide. And we don't write and, we have to write plus. Okay, so when we write word equations, we don't write and, we write plus. Give an indication that a chemical change took place. So that was carbon dioxide. One of the evidences that a chemical reaction took place is a release of gas. So release of gas. We can write in brackets CO2. Question 2 says 5 grams of magnesium burns with oxygen to produce 7 grams of white solid called magnesium oxide. This process accompanied by a bright light. Name the reactants. So we've got magnesium burns with oxygen gas. So this is magnesium and oxygen gas. Name the products. So it gives us a white solid called magnesium oxide. So that is magnesium oxide. So write the word equation. Remember, we write the reactants and then we write the products. So when it says word, so we have to write it down. Magnesium plus oxygen gas gives us magnesium oxide. Calculate the mass of oxygen gas. So the mass of the products or mass of the reactants. We start with the mass of the reactants, just easier for us. Equals the mass of the products. So then we know that the mass of so we need to know, so it is the mass of the magnesium, which is the reactants, plus the mass of the oxygen needs to equal the mass of the magnesium oxide. So then we know that the 5 grams of piece magnesium, so we know the magnesium is 5 grams. And we know that to produce a 7 gram of white solid of magnesium oxide, so we know that the magnesium oxide is 7 gas. we need to know 7 grams. We need to know the mass of oxygen gas. So I'm just going to carry on here. I'm going to write it for you so you know where we're at. So to solve this equation, we need to rearrange it. So the mass of O2 is 7 minus 5, which is 2 grams. So the mass of oxygen is 2 grams. Question 3 says, ethene is a substance that naturally produced by some fruits. It allows their ripening. It's also used in the production of plastics and organic compounds. Ethene can undergo a combustion reaction whose word equation is given below. Indicate the oxidizer, so it's ethene plus oxygen gives us carbon dioxide plus water vapor plus heat. Indicate the oxidizer in this combustion reaction. So the oxidizer often in combustion reactions is the oxygen. How can we detect the presence of released carbon dioxide? So the test that we use for carbon dioxide is we use lime water. Okay, and this should, in the presence of carbon dioxide, it goes from clear to cloudy. Indicate if this combustion reaction is complete or incomplete. Justify your answer. So this is a complete combustion. Why? It's because it gave us carbon dioxide plus water vapor plus heat. If it's incomplete combustion, only carbon and water are formed. So this is complete combustion. Because carbon dioxide and water were formed, or are the products. By referring to the knowledge or your own knowledge, indicate the color of the flame obtained during this reaction. So when we ever have complete combustion, it's always a blue flame. So the Bunsen burner, which is used in the laboratory for many uses, is supplied by butane gas. Also, the gas supplying your cooker at home is butane gas. When we place a sheet of glass above the flame, we observe a black deposit in case of combustion B. So here the key thing is we see a black deposit in combustion B, whereas there is no black deposit in combustion A. Why combustion A is a complete combustion? It's because we don't see any black deposits. Remember, with complete combustion, it gives us carbon dioxide plus water plus heat. Why combustion A is a complete combustion? Because there is no black deposit. Okay, so we know it's complete because we did not see a black deposit. Justify why combustion B is an incomplete combustion, and this is the key here, is because we see a black deposit. Okay, if we see a black deposit, that means it is an incomplete combustion, because a black deposit is observed. Combustion A produces a gas X that turns lime water milky. Name this gas. So remember, if we use lime water, we'd automatically know it's carbon dioxide. Milky, cloudy, it's similar interpretation, so both the same. So the gas is CO2, because we've used lime water, and lime water has turned from clear to cloudy in the presence of CO2. Write the chemical equation for combustion A. So butane is C4H10. So that is C4H10. Remember, combustion A is complete combustion. So C4H10 plus, because it's combustion, it's always plus O2. This gives us CO2 plus H2O plus heat. Write the word equation for combustion B. So we've got butane. Because also this combustion reaction, we write plus oxygen, which gives us, now with combustion B, it's incomplete. So this just gives us carbon plus water. Can we change this type of combustion from combustion A to combustion B? How? Yes, we can change it. So with incomplete combustion, there's not amount of oxygen, there's a lesser amount of oxygen. So what we can do is decrease the amount of oxygen received by the butane gas. So yes, we can decrease the amount of oxygen that is supplied to the butane gas. Is the combustion of butane gas endothermic or exothermic? It is always exothermic because there's a release of heat. So question 5 says transform the following reactions into word equations, then name the reactants and products. What am I going to do is I'm going to underline the reactants in purple and the products in green. So butane gas reacts with oxygen to produce carbon dioxide plus water vapor. So we've got butane gas reacts with oxygen to produce, so we put an arrow, carbon dioxide plus water vapor. Now the reactants are the ones that are before the arrow, so that's going to be in purple. The products is after the arrow, so that's going to be in green. Second one says potassium iodide is mixed with lead nitrate to give potassium nitrate and lead iodide. So we've got potassium iodide is mixed with, so it's plus lead nitrate to give us, we put an arrow, potassium nitrate plus lead iodide. Okay, so this reactants is in purple, so that's always before the arrow, and products are after the arrow. And then it says sulfuric acid reacts with sodium hydroxide to give water and sodium sulfate. So we write sulfuric acid reacts with, so we put plus sodium hydroxide put an arrow to give us water plus sodium sulfate. So anything before the arrow are the products, anything that's after the arrow is reactants. Hydrogen gas reacts with chlorine gas to form hydrogen chloride gas. So we've got hydrogen gas react, so that's plus chlorine gas to form, so we put an arrow, hydrogen chloride gas. So write hydrogen chloride gas, and remember anything before the arrow is reactants, anything after the arrow is products.